Hi, yes, I'll be speaking about metadata logs today. Some of you who have used databases for a while may think, I know what metadata logs do. They log metadata. Duh. No one's nodding. So maybe they all went to the other track. Shame on them. Or not survive on MySQL Island. Actually, there is more to it, and it's worth knowing, and I try and give you a why. Why should we know a bit more about how metadata logs work? So for a bit of context, Capsule is a multi-tenant CRM application. Earlier this year, we upgraded from MySQL 5.7 to 8.0. Is anyone here still on 5.7? Dreading it? Actually went really well for us until we had an outage. So we had an outage, so you don't have to. So what happened exactly was I was creating a new table, a brand new table to support a new integration. It was basically a innocuous change that we'd done a bazillion times before, so I wasn't worried. And then you won't believe what happened. I got paged, so pingdom detected, degraded service, and 503 errors all around. So that means some people were trying to access Capsule and were seeing this. Not ideal. So at that point, I realized it had to do with my DDL query. So I aborted the query. Eventually, the Capsule recovered by itself in just under 1 minute. But obviously, 1 minute is a long time for a customer or for a potential customer to not be able to access the product. So clearly, we needed to investigate what happened. We are on RDS, so the next stage of investigation was look at performance insights. Performance insights focus on the concept of weights, or weight events, and you should be able to see this purple bar, which is related to the MDL context weight event, which means that MySQL is waiting to acquire metadata lock on the table. So no surprises there. But really, beyond that, we didn't know what happened. It was a locking problem. So hopefully, this is a good reason to know why these things happen so you can figure out what the problem is. Most of us don't have DBAs. It's on us when the developers say that the database is stupid or the database is slow to help them change their ways. So before we dig any deeper, let's go over some of the basics of data logs and metadata logs. So logs obviously exist to isolate concurrent transactions in MySQL and the storage engine. So for most of us, InnoDB in MySQL will manage your data logs. So if I look at the puppies table, which is a table that we have in all databases, if a transaction needs to update the location of Paddy the puppy, then we'll lock this row. Or if a transaction needs data on all the puppies located in the UK, then we might lock a range of rows. Pretty straightforward so far. Now, metadata logs are looked after by MySQL server. Metadata logs basically look after your structures, so your table structures, your column names, your indexes, etc. And metadata logs will impact your data access because your data lives inside of those structures that you have defined. So let's say if I want to update the row number 4, I will take out a metadata log on the table. Now these logs can coexist. So I don't have to lock the entire table metadata in order to write or read to the table. So that's why these logs are called shared logs. They can coexist. They just signal that we're accessing the table. Please don't change anything in the schema whilst I'm using this data. But what happens if I want to update the data type of the location column? So in this case, I am updating the metadata logs, metadata of the table, in which case I don't want any of those shared logs knocking about on the table. I don't want to disrupt any of those transactions, so I request an exclusive log on that table. And that exclusive log self-explanatory. It can't coexist with any of the shared logs. So it will be pending until all those existing shared logs have been released. Now the question is, what happens if there are multiple transactions pending, waiting for that metadata log to be acquired? Which one will get priority? So if you believe RDS documentation, if you have two waiting, the second one will wait for the first one to finish. Don't believe everything you read on the internet. It's more complicated than that, and that's why I'm speaking. So I found the best way to actually wrap your head around it is to look at what's happening behind the scenes. Run some queries, see what metadata logs entries appear in the metadata logs table, and try and piece together what is happening there. So what we're going to do next is go over a couple of scenarios, just simple scenarios of different queries, different types of queries, interacting with each other, and we kind of work backwards. So I will show you the entries in the metadata logs table, and then you can use that to try and figure out what happens, which query gets priority. And then after that, we're going to talk about the implications in a real-world scenario, like a capsule. OK, so here's our scenario number one. So you'll be adding an index at some point in this scenario. In session one, we're going to start the transaction. We're going to insert a row, and this query completes just fine. In session two, we're going to alter the table puppies. We're going to be adding an index on the puppy location column. And as you can see, this query doesn't complete. It hangs. And what I wanted to point out in terms of the difference between these two, in session one, I started the transaction. I didn't commit it or roll it back, which means that the transaction is open, and all the logs I've requested, I will hold on to for the duration of the transaction. In session two, I didn't do that. Why? Alter table or create table, these are some of the queries that auto-commit. So no matter what I do, if I put in start transaction at the beginning, it's not going to change anything. Once the table is altered, the transaction will commit. I can't roll it back. I can't hold on to any logs beyond that. So this is really important to remember. OK, in session three, we're going to start the transaction again, insert into puppies again, and this time the query doesn't complete. OK, so in theory, we have two writes. They should be requesting shared write logs. They should be compatible with each other. So they shouldn't be blocking each other. But clearly, something is blocking. OK, so why is that? What we're going to do now is to look at the queries running in sequence and some of the entries that appear in the metadata logs table as those queries run. OK, so we're starting a transaction, inserting a row, and that will request a shared write log on the table, which is granted, so that consistent with the query completing. Session two, we're altering the table by adding an index, and this one requests exclusive log, which is pending, which makes sense because we have to wait for that shared write log to be released, and it can't be released until I've committed the transaction. Now in session three, repeating what we did in session one, starting a transaction, inserting a row, and requesting a shared write log, which is pending. So even though shared write logs should be compatible, because there's already a log in the queue, the shared write log will also join the queue. So the third query won't complete. So what I'm going to do next is roll back that query in session one. So I'm going to release that log, and then we're going to see what happens in the metadata logs table. But before I do, how about we have a little voting? Who thinks session one, the query in session two will complete first? If you're worried I'm going to catch you out, then I am trying to catch you out, so no pressure. No one. Session three, who thinks session three? Everyone is scared. Don't be scared. OK, you can think about it privately, but do try and pick one, because that's how we learn. OK, so I'm going to release the shared write log. And when we end up with shared write granted, an exclusive log pending. So has anyone changed their mind? OK, so in this case, they don't actually complete in order. So the share write lock will overtake the exclusive lock, even though exclusive was requested earlier. So the good news about this one is that exclusive lock won't be blocking any queries. So let's say I wait for a bit for the metadata lock to be acquired. That's not going to affect any queries that arrive later. So that's quite safe for application potentially, but it might take a while to get that index in there. OK, let's move on to scenario 2. So we'll start in a similar way. So we're going to start the transaction in session 1. We're going to write to the puppies table. But now let's say we had an incident in a capsule, and now we have to track the vaccination status of the puppies. So we're going to create a new table that references the puppies table. Create a table vaccination referencing the puppies table, and this one will also hang, like in the scenario 1. In session 3, we're going to start a transaction and write a table, and again, a similar situation. That one is hanging too. So a bit more complicated in that we have 2 tables here. OK, so let's see what happens behind the scenes. In session 1, start transaction, request share write on puppies. That's the same as before, so no surprises here. Now creating the vaccinations table. And that requests exclusive lock on puppies. So this is worth noting. We were working on a new table, vaccinations, that's completely empty, it's not being used. But because it references the puppies table, that's where we need the exclusive lock. And in 3, we're going to start a transaction again, write, and we're going to be waiting for the share write lock. OK, so let's do the same exercise. You can do it privately if you want to, but you can also raise your hand. Which one completes first, 2 or 3? OK, I'm going to release the lock now. OK, so this one might be a bit more confusing in terms of the output. They both granted. So exclusive lock has been granted, and the share write lock has been granted also. So how is that possible if they're not able to exist alongside each other? Well, the answer is they don't. What I mentioned before is that when creating a table, or altering a table, I'm not able to keep the transaction open. It will auto-commit. So what happens here is exclusive lock will be granted first, create table, vaccinations will complete immediately, it will release the lock, and then share write can be acquired. And that's how session 3 can complete. So in this case, they do run in order, and they can both complete, which is great. But what's important to underline here, it's not the exclusive lock being held that is stopping that share write from being acquired. It's the lock being pending. So it's that queue that's causing the backlog. So the longer we wait for that lock to be acquired, the larger the impact on your database and potentially on your application. OK, so now we have an idea of how these metadata locks can interact with each other in terms of individual queries. So let's talk about a scenario that is more similar to what happened in the real world. So imagine this is Capsule database, I wish. So you have a puppies table and a consultations table where we track puppy consultations. So every time I request a consultation or try to modify or cancel it, I will be writing to consultations table. And I will also be reading from the puppies table. That's because consultation references puppies. And some of those queries might be part of a larger transaction that might take a while to complete. It might involve all the queries, which might take a while. And that's fine because share read locks can coexist. So they don't block each other. So Normally, I don't have a problem with them existing at the same time. But now what I'm going to do is add the vaccinations table. That's going to request an exclusive lock on the puppies table. And now, because I already have some transactions that are holding locks on that table, I'm not able to acquire that lock straight away. So it will be pending. Now, the problem is, whilst it's pending, it won't allow any of the transactions to proceed, even though they're compatible with the locks that are currently being held on the table, so share rate locks. So now, every time I try to request a consultation, it will be blocked by the pending request. And if that takes too long to clear, then you develop a backlog, and MySQL will keep adding threads and long-running queries. And obviously, in most databases, you have more than 3 tables. You will have more of them, like you might have the puppy rating table, you might be writing to puppy images table, you might be writing to puppy training table, and all of them will try to read from the puppies table. So if the backlog is long enough, something will have to give. In our case, the bottleneck was actually our load balancer configuration. So we had a 60 seconds timeout on response from the application server. So that's what was returning 503s. But in other cases, actually my first hypothesis was they were running out of connections in the pool, so that could be a problem. Or if application can handle it just fine, the problem might be on the database side. It will keep adding threads, and eventually it will run out of resources. Okay, so before you become overconfident, the behavior is not set in stone. So at the start, I mentioned that we had, before this incident, we had recently migrated from 5.7 to 8.0. Previously, we would not had that problem. Actually, for 15 years of running Capsule, that was never a problem. And in fact, in 5.7, there's no exclusive on the parent. We're creating a table. So that's new behavior. Now we have exclusive lock that will block later queries. There's some other differences. For add column, for instance, there was an exclusive lock on the parent, but it was allowed to be overtaken by later reads or writes. In 8.0, that's not allowed. There is some differences based on the new instant algorithm that is available with 8.7. It wasn't in 5.7. I'll try to allude to that a bit, talk about it a bit later in the takeaways. Okay, so what can you do to avoid this happening to you? First of all, you have to know your application, you have to know your database, and you can't assume that you know it, and that knowledge is going to be valid forever. Particularly when you upgrade, you need to test, and you test multiple times, because it's all about timing. 1 second, you might acquire that metadata lock immediately, and in another second, it might not be like that, and you might end up with an outage. So make sure you do it multiple times. I have a little script on my GitHub that can help you run those tests on your test database to see how the queries interact and what actually happens in your database. So please do use it or use it as inspiration. One thing you can do is make sure you monitor your active threads. So that's something that the number of active threads, there isn't one normal figure, but you will know if they're growing faster than you normally expect. So that will set off alarm bells. You could ditch foreign key constraints. Sounds a bit extreme, but some people already do it. And at the very least, you can review a schema. If you struggle with this, it might be that you might have to review that and make some changes. You can use online schema change tools, but they don't work super well with foreign key constraints either, so use with caution. And there is one strange trick that you can use. So there is a variable that's dynamic that you can set per session. It's called max lock wait, and it refers to how soon it will time out if it's not able to obtain metadata lock immediather. So by default, it's set to, I think, a year, which is quite a long time. If you set it to, let's say, 1 second, you can try it out without much risk. if it's not able to acquire that lock immediately, it will just abort. And if you're not able to do it repeatedly, you have a problem. And you need to look at your schema and your application. And before I'm booed off stage, just shout out to Capsule, who helped me work on this presentation and also sent me here. I'd like to recommend it for any one of you who has a little company, a side project, a startup, and start thinking about how to keep up with all the customers, potential customers and leads. It's free to start, and you also get a free month in addition to trial with this code. All right, thank you so much.